Hello, thank you for joining the Muscadine Education Conference as part of the 2021 Virtual Southeast Regional Fruit and Vegetable Conference. I'm Patrick Connor. I'm a professor in the Horticulture Department at the University of Georgia, and I'm going to be serving as a moderator for this presentation. Pesticide CEU and CCA credits are available for most presentations offered during the live regional conference. Check the Pesticide CEU guide for a list of approved presentations and the participating states. The Pesticide CEU guide is located in the Event Resources tab under the Media Player. The guide is also available at the Resources Center located on the main menu of the conference platform. Please note, pesticide credits will be only available for registered attendees only during the live conference. Credits will not be available for on-demand viewing. There's a simple three-step process to receive pesticide CEU and CCA credits. First, go to the audience chat box located on the left side of your screen and type your first name, last name, and the states for which you're requesting credits. Again, go to the audience chat box located on the left side of your screen and type your first name, last name, and the states for which you're requesting credits. You will need to do this for every presentation to request CEU credits. The second step is to sign out at the end of the presentation. To sign out, go to the audience chat box and type your first name, last name, and the states for which you're requesting credits. You will be reminded to sign out at the end of the presentation. The third step is to complete the pesticide CEU registration. You only have to do this registration one time during the conference. This is not required for every presentation. To access the pesticide CEU registration web link, go open the pesticide CEU guide on the Event Resources tab located under the Media Player. The pesticide CEU registration web link is located on the front cover of the guide. This presentation is pre-recorded to reduce technical difficulties, but we will be answering your questions live at the end of the presentation. You can submit a question at any point during this presentation by typing your questions in the question box and pressing send. Don't forget to thank our 2021 conference sponsors and the exhibitors by visiting the virtual trade show and the featured products pavilion. Lastly, don't forget to join us each morning for coffee chats and each evening for networking. Check the conference agenda for details. Now I'd like to introduce Bill Cline, who is a plant pathologist with North Carolina State University, who will be presenting diseases of muscadine grapes in the Southeast. Bill is a longtime researcher in blueberries and muscadine grapes and is located at the Castle Hayne Station in North Carolina. While muscadine grapes are a native fruit adapted to the hot and wet conditions of the Southeast, large plantings can still suffer from a number of diseases that reduce profitability. This talk will guide you through diagnosing and treating some of the most important diseases and abiotic problems you may encounter in your vineyard. Okay, now Bill, I'll have you take it away from here.
Hello, this is Bill Cline with North Carolina State University. Today we're going to cover an update on muscadine grape diseases and also talk a little bit about new fungicide data from 2020. First, I'd like to say muscadines are tough. They are a very disease-resistant grape, resistant to Pierce's disease that kills bunch grapes. We often see muscadine vineyards are not sprayed at all for disease control when grown for wine production, and backyard muscadines are usually not sprayed. So just a really tough grape, really resistant to a lot of fungal pathogens that cause problems for bunch grapes. So no downy mildew, bunch grape anthracnose, or botrytis gray mold. When we think about leaf and fruit diseases of muscadines, they're mostly caused by fungi. And these fungi spread by microscopic spores that are spread by wind or splashing rain or insects. And the spores require moisture to germinate and infect. If you go out in your vineyard in the wintertime and look for signs of where these pathogens might be, they're going to be up in the vine, up along the cordon. It will be old infected plant parts, fruit pedicels up in the vine. And in the spring of the year when the new leaves emerge, all of that old debris that's infected is still up in the vine. And if you look at this slide, you can see new growth coming out, new leaf shoots, but also a lot of old mummified fruit and fruit pedicels, so that those fungi are right up in the vine. And that's where it carries over from one year to the next. Once you get into the season, you start seeing symptoms of these diseases and also signs of the fungi that cause diseases. Now, signs are where you actually see the fungus itself, spores or mold on the surface of fruit or leaves. And symptoms are just what it sounds like, the symptoms that they cause. So when we talk about fruit rot diseases on muscadines, you'll see very often, if you look in the upper right corner here, bitter rot. That's a sign of the pathogen where you see that actual black mold growing on the berry. And in the lower left corner, a ripe rot, you see orange spores on the surface of the fruit. So these are the indicators of fungal disease in your muscadine vineyard. Just another shot here. This is a close-up of ripe rot at harvest. You can see the symptom, which is the brown rot, and the signs of the pathogen, which is the orange spores on the surface of that rot. Leaf diseases, very similar. You'll see necrosis and spots on the leaves and a number of pathogens that cause diseases of the leaves of muscadines. One of the earliest ones is black rot. So earliest in the season, you will see black rot on the leaves as one of the first pathogens that shows up in the springtime. Another pathogen that causes problems on muscadines is powdery mildew. And this has a little bit of a different look from the other diseases. The powdery mildew forms a white, powdery, thin fungal layer on the surface of the fruit. And after infection, the fruit has scars. So the upper picture, you see the white powdery growth on the berries, and in the lower picture, you see scars on the fruit, a russeting appearance. In the center of this photograph, you see one small grape that has the same sort of powdery look. Again, this is indicative of powdery mildew, which is a fungal pathogen. And later in the season, that grape would look like this. The grape in the lower right of your screen is not infected, but the other two have powdery mildew symptoms, that brown scarring on the surface of the fruit. So what do we do about these diseases? I know we think about fungicides for disease control, but there are a lot of other things that you do in the vineyard that contribute to disease control. So let's take a look at the whole package of what you can do to manage diseases. Your tools are starting with clean plants, using disease-resistant cultivars, using your cultural practices to your advantage, how you fertilize, how you manage the canopy, and finally the fungicides. So fungicides are not your only tool, but they are a very useful one. In starting with clean plants, I think in the future we'll see a lot more muscadine vines that are propagated through tissue culture. This has happened in other small fruit crops, and we see a lot of tissue culture plants in blueberries and strawberries. I think that will be the case in the future with muscadines as well, just to avoid having any plant pathogens that travel with new plants going to the field. So the picture you see here, muscadines growing in an artificial medium in a lab. This is a way to propagate and produce clean plants. We talked about muscadines being tough, and that's what disease resistance is. They're resistant to Pierce's disease, to downy mildew, botrytis. Lots of different pathogens that affect bunch grapes just do not affect muscadines. As a general rule, the most resistant muscadines, the most disease-resistant ones, are the ones that are dark fruit. So when we conduct fungicide trials on muscadines, we don't even try to do disease control tests on the black grapes because they're just really clean. So most of our fungicide work is done on the bronze cultivars. Cultural practices, if you can avoid over-fertilization of muscadines, I think you'll stand a lot better chance of being able to manage diseases and get get good air movement through the vineyard. You want the canopy of the vineyard to be sufficient to shade the grapes and to provide the photosynthetic energy, but not so lush that that you don't get air movement through the vineyard. So that's a balancing act for you as a grower with fertility and irrigation. With harvest, especially with the fresh market cultivars, a timely, complete harvest is really critical. They have to be handpicked multiple times as opposed to a once-over machine harvest for wine grapes. And I hope you think of your winter pruning also as a disease management strategy. Winter pruning removes a lot of the overwintering disease plant parts and is one thing that aids disease control in that time of the year. Now, I'd like to talk a little bit about fungicides, the sprayers you use, and spray timing. Typical sprayers for muscadines, with an air blast type sprayer, I'd like to see 20 to 40 gallons of water per acre. That's a minimum. With a high pressure sprayer, 50 to 100 gallons. And again, that's sort of a minimal volume. You really want to cover the vine well and have a lot of water going out. And you also have to have a sprayer that's designed to reach the grapes underneath the canopy. Now, this is a combination sprayer that illustrates the two types of heads you might see on an air blast. One that works really well for muscadines and one that doesn't. So this old AgTech has a upper cannon that directs spray downwards, but it also has the lower unit that is a air-assisted air blast sprayer that blows upwards. And that's really what you want with a muscadine grape, because you have to be able to spray underneath the canopy, loft up those vines, and so the spray contacts the flowers and developing fruit. Otherwise, you don't get any protection from your sprays. So you're looking for an air blast type sprayer with nozzles and fan assist. And the picture on the right here shows an air blast going through an apple orchard, just showing that upward movement of the fog. Now, spray timing for muscadines is a lot simpler than for vinifera grapes. They just don't have to be sprayed nearly as much because they're resistant to so many diseases. So your sprays begin in mid-May, before the disease is visible. Flowers are not open yet, and the shoots are 6 to 10 inches in length, and you're applying fungicides every 2 weeks through early August. The early season sprays are the ones that will pay you back. They're the most effective sprays. Spraying later, closer to harvest, is not as effective. These products are protectants. They have to be applied before disease symptoms appear. And always write down what you've done. So if something goes wrong, you'll know what you did and can change next year. This is just a quick overview of sprays for vinifera grapes versus muscadine. So vinifera on the left, this is from Dr. Mizuho Nita's spray guides in Virginia, and just quite a number of sprays that are applied on the vinifera type grape versus the muscadines on the right. Just a few sprays, but they are critical. And again, early season is better than late sprays. So our standard fungicide recommendation in North Carolina is to start early with mancozeb, then alternate rally with Captan every 2 weeks. Where ripe rot is a problem, that's the disease shown here, that sort of brown sunken rot. Where ripe rot is a problem, you would want to include a strobilurin fungicide like Abound or Pristine or Flint. And our recommendations are published every year and updated every year at smallfruits.org. This is the 2020 regional guide. This also covers insects and weed control, and it's something that we try to keep up to date and review every year. A lot of authors involved, a lot of expertise involved in producing this document. Now, one question we had in 2020 was, what about newer fungicides? A lot of them have not been tested on muscadine grapes. We didn't know if they would work or if they were safe. The picture on the right shows a product that did not do well on Doreen bronze muscadines. The picture there shows spray burn. So that's not disease. That's just a burn from a chemical that was sprayed on the grapes. So we'd like to avoid that type problem. So the experiment that we conducted in 2020, we looked at the fungicides that had not been tested on muscadines. We tested for crop safety and for fungicide efficacy. And the experiments were conducted in North Carolina and in Georgia in 2020. And the project was funded by the Southern Region Small Fruit Consortium, Phil Brannon at UGA and myself, Bill Cline at NC State. And so the goal was to take our standard fungicides that we know to work and just sort of set those aside and look at fungicides that we have no idea whether they work or not, but they're labeled for grape. So the idea was to give you as growers more tools. And so we looked at these new fungicides in the column on the right, a number of products that we just had no data for on muscadine grapes. As far as how the experiments were conducted, these were randomized, replicated trials, one in North Carolina, one in Georgia. The fungicides were applied 4 times in North Carolina, early season sprays, and 6 times in Georgia. Actually, I think that was a total of 8 sprays in Georgia, so that's an error. We evaluated the vines for crop injury in August and September, leaves and fruit, and then evaluated leaf spot and fruit rot in North Carolina. Now, the Georgia vineyard was a young vineyard, did not have a lot of disease pressure, so most of our good data on disease incidence and severity came from the North Carolina trial. Again, just trying to evaluate these fungicides so you know whether to use them or not. So this was a pretty extensive test, 11 or 12 different fungicides. And if you look across the top of this table, I know the print is small, but we looked at ripe rot, bitter rot, macrophoma rot, the percent marketable fruit, and angular leaf spot, which was the predominant leaf disease in the North Carolina trial. And rather than try to read all this to you, what we're going to do is just highlight the products that worked and the diseases they worked on. So if we go to the next slide here, everything that's in light purple is something that did better than doing nothing, that did better than not spraying. So we were really delighted to see a lot of fungicide efficacy against bitter rot, macrophoma rot, and these increases in percent marketable. Now, the first column that says ripe rot, we just did not have enough ripe rot disease. That particular fungus did not cause enough disease for us to get a good evaluation. So we have no data on that one. But for the leaf spots and for the other 2 major rots, really got some good numbers there. As far as percent marketable, that tells us which products are worth your money to apply, and we have 8 products there that really made a significant difference in the percent of fruit marketable. So just to recap, we got our standard fungicides that we know work, and then the new products that we evaluated in 2020. Now, this is 1 year's data. We'll have to continue to test these products, but we're really pleased that a number of them were active and gave us a significant increase in marketable yield. And the ones in the right-hand table that have the asterisk after the name were the ones that gave us a significant increase in marketable yield. And also important, none of these products caused any damage to the grapes. And now we have some confidence that these are safe to use, and the ones that have these stars beside the name are efficacious. So we feel like we're going forward here with a number of new products. So again, we feel like we had success. We have the data now. We need to repeat these trials. No injury. We will expand our regional recommendations based on this experiment. It gives us more fungicide choices, more modes of action for disease control. And again, this was funded by the Southern Region Small Fruit Consortium. And I really appreciate the funds that allowed us to conduct this work. And hopefully this will greatly expand our fungicide choices in the future. That's about all I have for today. I hope this information has been useful for you. I'm certainly excited myself for the new data that we have on these fungicides that we can use in muscadines. We'll continue to build on this knowledge and try to provide more options for you for controlling disease. I know this has been a problem, especially with some of the fresh market cultivars, and I think we're on to something here. So really pleased to present this information and glad to answer any questions you may have. Thank you.